Hey, hi. Hello, everyone. This is Visal, and I'll be your math instructor for this term. Are you able to hear me?
Yes. Hello. Good morning.
Yeah, good morning.
Yes, sir.
Yeah, yeah, good morning, everyone. And so we'll
Good
just wait.
morning, sir.
Yeah, good morning. So we'll just wait for some more minute. I guess let's other people also join, and then we'll start. So our today's uh, so I'll just brief you what are we going to do it today. So I'll just summarize the concepts that we have if you have went through the lectures of week one. So we'll just summarize that, and if you have a doubt, any doubt, we'll just take that. So this is what we are going to do it in the today's session. So I'll just wait for more 2-3 minutes, and then we'll start. Okay.
Okay, sir. So I have doubt in functions and relations. Can you please explain that?
Yeah, I'll explain that. I'll start maybe after 2-3 minutes, and then we'll go through that. Okay, I'll explain you everything.
Okay, sir.
Okay.
Good morning, sir.
Yeah, good morning.
Sir, what we are doing in this session?
Yeah, so we'll summarize the concepts, whatever is there in the week one. We'll just try to summarize that in today's session. Okay, and after that, if you have any doubt in any of the questions, we'll just take that after finishing, after summarizing that.
Yes, sir.
Yeah, so this will be our agenda for today.
So there was a TA session scheduled for last night, and that didn't happen. Do you know why?
What?
There was a TA session that was scheduled to happen yesterday, 8 p.m., but
Yeah.
that never happened.
That happened like I checked it yesterday. It did happen from 8 to 10, I guess, yesterday night.
Yes, it happened.
Yeah,
Oh,
it happened.
I don't know. I tried joining, I mean, pretty much for the entirety of 8 to 10, but I was just never let in.
Okay, I guess
Same for me.
maybe in the calendar it should be there. If it's not there, you can just like I just posted those link for the like the Gmeet link on the Discourse also. From there also you can take them. Like
Yeah.
today also you have that session. I guess today you have from 6:30 to 8:30, whatever I can recall. Yeah,
Yeah, yesterday we check it, I check it, no one has joined into the meeting.
yesterday.
Okay.
No, sir,
I
it's not on 6:30. It's on 8. It's overlapping with the statistics class.
that's see one more thing I want to clarify. So those are TH session. Okay, so that may collide, like that may overlap with some other session also, but the session whichever will be taken by the instructor, so that won't overlap with anything. Okay,
But so we clear doubts in TA session. That's also
anywhere
important.
you can
And
go,
solve
any.
with a session for statistics. That's also important. So if that will also overlap, it will create a problem for us. So.
No, what I was saying is, see, you'll be having a lot of TH session. Okay. So TH session for sure will overlap with some of the other courses also, because then there won't be like we have that fixed time, right? The time constant is there. So whenever we are scheduling the session, the instructor session won't be overlapping with any other courses. Like any other courses means foundation courses, which are the courses you have opted for, 4 or 5 courses that you have, four I guess you have opted for, or maybe less, but that won't overlap with anything. But yeah, TA session can overlap, because TA session you have a lot of TA sessions, so you can go to the other TA session also to just clarify your doubts. Okay, are you getting my point? So you'll be having basically from now you'll be having seven, 4 TA sessions will be there. It's like office hour. You just have to go there, ask your doubt, and you can leave. This session, whichever will be taken by us, like me, and there are other instructor also for your maths one. those won't overlap with the other courses, with the stats or English 2 or computational thinking. So that won't overlap. The instructor session, okay. So those are three. One will be the summary session. The other will take your doubt, and the last one will be
Okay, sir.
the solve with us. So where you'll be solving the questions, okay. But the TA
Okay.
sessions, there will be like all the doubt sessions will be there. You can go there. You can ask whatever the doubt you have. You can leave. Okay.
Okay, sir.
Yeah. So this
Sir,
was the point. So
So,
that
sir,
may
next
overlap.
session for math uh is tomorrow, and that is PYQ discussion. Can we ask question our doubt there?
Yeah. So today in the PYQ discussion, I thought of that session will be taken by the TAs, and there they'll discuss the week one ka previous term questions. So whatever the 10 term or 15, 11 term that has been done in for the maths one here. So he'll just pick out some of the questions from the previous term, and that will be discussed, and that basically helps you a lot in the final, the qualifier paper.
Okay, sir.
Yeah, so that's why it has been kept there. Yeah.
sir, I have sent a link in the chat. It's for the reference book that we are given for Maths 1. Can you open that?
So is this is a reference book?
Please go to page 11 when you do.
Yeah, page 11.
Yeah, here under the transitive relations example,
Yeah, it's an error.
the R4 is an error, right?
Yeah.
Okay, thank God.
So yeah, there won't be any. Most probably there won't be any mistake on the portal. Okay, on the book there can be some error because the book was been done later and it went through the proofreading. But I guess there can be some error, like the reflexive one. This is the error.
Yeah.
Okay, but there won't be anything on the portal like the portal activity practice and graded, that there won't be any mistake because that went through the proofreading 4 or 5 times. Okay, the book went just for the one time, so that's why they can be, and I guess this is the only that I can remember from the previous term also that we have to correct it. But yeah, so this is what I have to say. So yeah, so there is an error regarding, I guess, reflexive relation, I guess, right?
I think transitive, not the reflexive.
Sorry, transitive. Yeah, my bad. Okay, so let's start. I'll just start the session now. Can you see the screen? My screen is visible to you, right?
Yeah.
So I'll just start with the week one concept. The week one concept basically is pretty not that difficult. You just have to go through. If somebody would have done maths in class, maybe I guess this is the maths that you would have read in class 9th, 10th, or maybe lesser. So, but yeah, but I'll just go through all the things in a glance, and then we'll discuss the relation function in a brief because I guess most probably many of the people will be facing issue in relation and function. Okay, so the type of function and the relation that has been given, equivalence relation that has been given there. Most probably you'll be having doubts there, and after that we'll just take the doubts of from your side. Okay, so I'll start with the sets. Or before sets, there are some numbers like natural numbers, real numbers, rational numbers. I hope there won't be any issue in that. If you have, you can just ask me. regarding like anything if you have regarding natural and integer. I don't think so there will be any doubts, right? So do I need to discuss that, or we can directly discuss from the set, uh, if
Yes,
you
sir, we
want?
can start from set.
Yeah. So you're already
Just
aware of
one,
the nature. Yeah.
just one question there. Whenever we get n, we should always assume that it includes zero, right?
Yeah. So there's a
Okay.
convention that we are using. So you have to include zero. Most of the books doesn't include, or many of the books includes also, but our convention. So it's like just we are taking, and in the natural number you have to take zero every time. Okay.
Thank you.
And yeah. So let's come here. So set basically is a collection of a well-defined item. It's like and it can be of and this set can be finite or infinite. Basically infinite is like somebody now was saying about the natural number. Okay, so that can be a set of infinite, like that can be an infinite set, right? Why is it an infinite set? Because it will be having, if I'm just taking a set n, so it can have an infinite number, right? Correct.
Yes, yes, sir.
Yeah. So, and similarly for the finite set, you have some, like for example, a set here it has been written set of a natural number less than zero. So it will start from where? 0 to 9. Okay. So it has a 10 numbers, right? So it's a finite set. You can count the element or the item of a set, right? So that's why we generally call it as a finite set. Okay. So there's no like a set that is a collection of a well-defined items, and then it can be classified as a finite and infinite. Infinite where you can't count the number, like it's like for example a set of n, like a natural number n. Basically that's a natural number and then it starts from 0 and will go till infinite, the number that you can think of as big as possible, right? So that's a infinite set. And then you have a finite set where it's the number that you can, the items that you can count of. Let's for example the set of a natural number less than 10, or maybe a name of some 10, 11. So the players who are playing England versus India, that's test going on. So you have some 11 players there. So you can count that number, right? So it's like we can just write it out, all the players' name who are playing today's game. So that is going between India and England. Okay. Or the set of all days in a week, or a set of all month in a year, or anything. So can somebody give me a finite set example? One example more, whatever I've said, like excluding those.
A set of
Set
all
of,
students in the class.
yeah,
Correct. And the example of infinite set.
set of all
Set
real.
of
Natural
prime
number,
numbers.
set of natural number, set of even
Set of
natural numbers.
correct. Yeah. So as we have understood the set, now we'll go through. So there are some properties that you should be there in your mind, and this if you'll go through some of the previous term paper, most of the time these properties generally are asked in the questions. Okay, in the statement based questions they can write you which of the following statements are correct, and then you can be given like what do you call the each element of the set, basically the item, and even the orders are important or not, or the duplicacy is important or not. So this type of problems can be asked. So what I'll so basically, so what are the elements? Let's for example I was saying the set of a natural number less than 10. Okay, so each element whatever was there, so you'll be writing like this, correct? So it will be something 0 1 2 till 9. So each element that is 0 1 2, those are basically called as the items of the set. Okay, and then one more important thing is order is not important in a set. Wherever if I'm writing 0 1 2, or I'm writing 1 0 2, both are same. Okay, so the order doesn't matter in a set generally tells you what are the like the items present in the set. Okay, so that's 0 1 2 or 1 0 2. So whatever you want to write, however you want to write it, doesn't matter. So order doesn't matter in a set, that's the very important thing. And the duplicacy also doesn't matter. If I'm asking you what's the cardinality, basically cardinality is the number of items that are present in a set. Okay, so can you tell me what's the cardinality of this set? Set of
Excuse
natural number.
Three.
Set of natural number less than
10.
10. Yeah, 10.
10.
Correct. Yeah, for this it is 3. Okay.
Yes, sir.
Yeah. So even though if
elements of
so the order doesn't matter, the first thing, and the second thing is duplicacy also doesn't matter here. Even though if you're writing 0 1 1 2, so the sets, what are the items here? 0 1 2 only. Okay, so the cardinality would be 3 only. Okay, so I told you 4 things in a property of the set. The first thing is each element are known as, each items is like each elements are basically
excuse
sorry,
me.
yeah,
Sir, 0 can be considered an element.
yeah, why not?
Because we are considering 0 as a natural number, so it can be considered as an element in a set of natural numbers.
Yeah, correct. Because we are considering here 0 as a natural number, so we have to consider that. And each item is known as the element, so we have how many elements? Basically 3 elements here, 3 here, and 3 here also, because we just have 0 1 2. We don't have anything else, so that's why there are only 3 elements in the set, this S3 also. Okay,
sir.
so each items in the element are the, each items are called as element. Basically it's like not that important, just the term you should be knowing. Yeah, so this is important that the order can vary, you can write it in whichever order you want to, and the duplicacy doesn't matter. If you're writing duplicates like 1 5 times also, that doesn't matter, because the number of elements or the elements that are present in the set should be same, either you're writing 0 1 2 or you're writing 0 1 1 1 1 1 2, so it's like basic same. And then the cardinality is basically the number of items or the elements that are present in the set. Okay, so as you told, for this one, for this S1 it was 10, for S2 it is 3, S3 it is 4. Yeah,
S3 is also 3, no? Because 1 is repeated 2 times.
yeah, so that's why I told. Yeah, oh sorry, 3. Let's come to the subset. Okay, so if you have any difficulty, I don't think so there is anything in the set that maybe. Okay, if you have anything you can just ask me. I'll just wait for some 5 seconds.
Sir,
Yeah.
sir, is it necessary for set to have common characteristics?
It's not no, it doesn't snipe, just a collection of some defined numbers, not numbers, some elements. It should not be, it's not compulsory to have some common factor. Okay, like for example you can have some name A B C D and then you have Dhoni or something, so you have just 5 cardinality here. Okay,
Okay.
yeah.
Sir, I have doubt in the part of intersection and complement in this.
What should I?
Sir, I want to
Acha,
know
intersection. Okay, I'll go there. So I'll just discuss the subset and then I'll discuss that.
Yes, sir. I also have same doubt in intersection and union, but I have that in number line. Like when element is represented by a curly bracket or a small bracket or a big bracket, then what does it represents?
Okay, I'll just go through that. This is a very important one. Okay, I'll just.
And sir, my doubt is that in many questions there is a use of some identities like a intersection identity relation is equals to that same set. That type of
So the
formula.
brackets. Okay, yeah, I'll just discuss that also. So. Okay, so they're basically in the maths. They're this small bracket that we use, and then we have curly bracket, and then we have a close bracket. This is basically open bracket. Okay, whenever you have been given something like 0 to 5. Okay, what does that mean? Small bracket. Can somebody tell me?
From 1, 2, 3, 4. This includes 1, 2, 3, 4.
Yeah, correct. It's basically, it's not, so it's from 0 to 5, but it's not including 0 and 5. Okay, so it's, this is not included. Other than that, everything is included from 0 to 5. Even 0.001 is also included, and then till 4.99, whatever the smallest number that you can think of, less than 5. Okay.
Okay, so sir, I had doubt that if it will include only 1, 2, 3, 4, or all the numbers between 1, 2, 3, 4.
So all the number, it depends on whatever has been told to you. Like if it's like real number from 0 to 5, then it will be including everything except 0 and 5. Okay, and if it was an integer number, you just have to include 1, 2, 3, 4. Okay.
Okay, sir. Okay,
Yeah,
sir.
if it's just given that it's like 0 to 5, then it's all the number from 0 to 5 excluding 0 and 5. So 0 and 5 is not included. Other than that, everything is included. And then for the curly brackets, like just the exact those numbers, like 1, 2, 3, 4. So all the numbers should be given in the curly bracket. And then in the close bracket, if it's been written 0 to 5, that means 0 and 5 is also included. So 0 to 5, though it's there already, but 0 to 5 is also included. Okay. So this is what we
Okay, sir.
generally call it. So close bracket, if you have to write it in the mathematic form, you generally write it like this, right? 0 to 5. So everything from 0 to 5. And if I'm
Okay, sir.
writing close bracket, that means we are just equating. So 0 and 5 is also included. Okay. And for this curly bracket, just write it like x equals to 1, 2, 3, 4. Okay. Whatever the number that has been given in the curly bracket, that should be available. That is the only data points that are available. Okay. So is it fine now?
Yes, it's fine. So can you please solve the question that is given in the activity?
Yeah, I'll solve. So first, I'll just go through the summary. Otherwise, if I'll
Okay, sir.
take your doubt in the starting itself, I think so we won't be able to complete. And the end, I'll take your doubt. Other than
Okay, sir.
that, we have a session that will be taken by the TH also today. I guess that's
But
so
sir,
that's
that
not
is overlapping with start session solve with us. So
okay. Okay, but yeah, okay. Apart from this, what was the doubt? You were asking about the intersection and what was the doubt?
yes, sir, intersection of
Yes,
sets.
Okay.
sorry, that's called interval, right?
So my
Hmm.
doubt from identities.
Okay. I'll just go through the intersection first, and then I'll go through your doubt also.
Okay.
So see, basically, what are the element that we use it? Basically, you use union of two sets. If you have been given two sets, okay, and then you have intersection, and then you have complement. How do you see? Basically, if you have a set like, let's for example, I'm just giving a pictorial representation of some set A, and there is some pictorial representation of B, right? So what is the union here? It's like all the elements that are present in A or B. So or is important here.
So can you explain this union and intersection on that number line? I mean that bracket thing with that bracket thing.
That bracket thing. Okay, okay, I'll explain you. So let's have an example like A. You have a set A. Let's for example you have a set in the form of something like um, that takes 1, 2, 3, and then you have B something like 3, 4, 5. So what should be the union? I told you union is what? It should be present in A
1,
or
2,
B.
3, 4, 5.
Yeah, so 1, 2, 3, 4, 5. Okay, so that's the very simple. Then you can show this A union B would be what? Those are present in A or B. Okay, so it's like basically 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, and now if I've been given you in the form of some on the coordinate, you have a value, that x value, and that x value is from, let's for example, this is from 1 to 5. Okay, and then you have x basically is belongs to 1 to 5. Okay, this open
Yes.
bracket, or y belongs to some, let's for example this is 3 to 10. Okay,
Yes, sir. Yes,
so
sir.
this is x, and then you have, this is not included, x and 5 is not included here, right?
Yes. Yes,
And then
sir.
you have from 3 to 10. Okay, so what should be the
Yes.
value? X of union of y. What did I say? It should be present either of the two. Okay, it's like or. Okay, so you don't have to exclude this 5 and 3. Okay, one is not present in x and y both, right? So that's why it should be open here. But 3 is present in one of the two, right? So it should be, and 5 is
Okay.
also present in one of the two, but 10 is not present in both the cases. So that's why we'll be writing something
Okay.
like this.
Okay.
You
So
got it,
if
right?
an element is present in either of the set, then we will be including that.
Yeah, those will be included. This is what I said, right?
Yes. Okay, sir.
So
So
as
here
4
you
was not present in A, but we wrote it here, right? A in A union B, because
Yes, sir.
one of the two. It's like or condition. Okay, or means like either of the two.
Yes, sir.
so in
Got
the
it?
answer when you write 1 comma 9, you should be using the square brackets, right?
Where?
X union y is equals to, you wrote in brackets 1 to
Here.
the last one at the bottom.
Okay, this one.
No, both 1 and 10 are not included, right? So that's why it's open
Okay,
bracket.
okay, okay.
Because 1 and 10 was not included from the starting itself. 1 is not included in the X. 1.11 like is included, so that's why that will be included in the union also. But X is not there in any of the cases,
Right.
like in X or Y. So if it's not present in both of the cases, you can't write. It should be present in one of the two.
Okay, sir. And here, if we have to find the intersection in the same set, then what it would be, sir?
Okay. So if you have to find the intersection, what is intersection first? What do you call the intersection?
Which is common in both the set.
Yeah, it should be present in both of them. It's just like a or and case, right? It should be present. If it's not present in one of the two, you can just exclude those, right? But
Yes,
what
sir.
is A intersection B for this case?
3.
3.
3.
Yes, sir.
Correct. So if I have to write it here, what are the values? Those are present in both the cases. From 3 to 5, correct?
Yes, sir. Yes, sir.
3 to
3
5.
is
Now you have
not
to,
in.
yeah. Okay. So in the intersection, 3 should be present in both the cases. Is 3 present in both?
No, sir.
No. Right?
Yes, sir.
Because 3,
Yes,
no,
sir.
no.
3 is present in both.
In Y,
In Y is also in X also. Because X is from 1 to 5. No.
that is fine.
No, it's 3
I'm
is
just
not.
saying about the Y.
Okay, no. 3 is not
Not
present
present.
in Y.
Huh. It's not present. So that's why it's not be present in the intersection also, because it's not present in one of the cases. It should be present in both the. That's why, that is how you have to include that in the X intersection Y. Okay,
Yes,
it
sir.
should be
Yes.
present in both the cases. It's like and case. So 3 is not present in one of the cases, but 5 is 5 present in both the cases?
No.
No, because 5 is not present in X. So how can you
Yes,
write
sir.
it? So again, it will be open, right?
Yes, sir. Okay, sir. Understood. This was my doubt, sir. It's
Okay.
done now.
So can we move to the next part? I guess we
Yes,
were
sir.
discussing the subset. Subset. Anything else till now? If you have anything, you can just ask me. We'll just go there and discuss.
Can you
If you
can you
don't have, I'll
also
just
can you also do the subtraction on the number line?
Okay. What do you call the subtraction? Subtraction is basically the element that is present in so the values which are present in the first should not be present in the second. If I'm writing A minus B or X minus Y, correct? I'm writing X. That means what? The elements in X that are not present in Y, correct? If I'm just writing it for A and B, what should be the value for this case?
1, 2.
1, 2, correct? So in the element 1, 2 are present, but that is not present in B. B 3 was present. That's why we have excluded that. Again, for the same case, if I'm writing X minus Y, what should be the value? Can somebody tell me? What are the values those are present in X but not present in Y?
2, 3,
One,
Three.
1 to
Open
3.
2 and 3, I guess.
1 to
1,
3.
3.
Give me the value in the form of open and close. Yeah. So
1,
like just
3 in open
1,
bracket.
3 open bracket.
1,4 in open brackets.
1,4.
Actually, 4
Okay.
will also be
Okay.
present. No, 4 will not be present.
1,3 or
3.
4.
1,3.
3.
3.
And what should be the value? Is 1 present in X?
No.
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 Yeah. So was 3 present in X?
Yes, sir.
Yes.
Correct?
Close bracket.
Close bracket there.
Yes, sir. 3
Close.
will
No.
present.
No, sir, open bracket. Because y we have removed, right? Oh, y does not include 3. Okay, yes. Close bracket.
Correct?
Yes, sir.
Yeah.
Is it clear to everyone?
Yes, that was
Yes.
fun.
But it's the same to say 4 open bracket.
4 is not. So 4 is present in X. Okay. But 4 was present in Y also. That's why we have excluded that. X minus Y is basically the elements or the values which are present in X, but that should not be in Y. This is what we call X minus Y. Okay. That's
Yeah,
why we are
but
not excluding 4. Yeah.
yeah, but in the open interval or the open curly bracket, that's not included before. So it's also included the 3, but with no closed bracket. It's the same. No?
Where in X minus Y or somewhere else?
Yeah, in X-Man Hawaii.
Yeah, in X minus 1, 4, so it's not
No,
present here.
what he's saying, sir, is 1,4 with both open brackets.
Yes, it's the same.
No, because Y, so you can see that 3.1 is present in Y, right? And that is present in X also. Did you get my point? So we just have to take out the values which are present in X, but that should not be in Y. Okay, so 3.1, if you are taking out 1 to 4, so 1 to 4 includes 3.5 also, correct? And that 3.5 is there in X and Y both. 3.5 you can't take, right? So you have to take till what? Value 3.
No, okay. I got it.
Got it, right?
Thanks.
Yeah.
Yeah.
So we discussed union, intersection, and complement. I guess the complement is pretty simple. So union, intersection, and set difference we have discussed. Correct. Let's come to the subset. Okay. So if you have been written something like this, X subset of Y, that means if every element in X is also an element of Y, then only you can write it something like this: X subset of Y. Okay. Can you give me one example? Okay, I gave. So here it has been written X that has elements A, B, C, and you have a Y, A, B, C, D. Can you write it? Is X a subset of Y?
Yes.
Yes, sir.
Correct?
Yes, sir.
X is a subset of Y. So it's pretty simple. If all the elements in X is also present in the element of Y, you can directly say that. So I'll just give you one more example. So if you have been given something like this, X equals to 1, 2, 3, 9. And you have Y equals to is X a subset of Y?
Yes.
Yes, sir.
Yes, right?
So, but the confusion is when we discuss proper and improper subsets. That's when it becomes a little.
Okay, we'll come there. And then you have is A a subset of B?
Yes.
Yes.
So we have discussed this. Now let's come to the proper set. Yeah, proper set subset is basically, see, if you have been given a set X that is the proper subset of some another set Y or A is proper subset of B. If and only if, so all the condition is holding. The only condition that it should not hold is X should not be equals to Y. That's the only condition that it should not be holding. Okay, so whatever the example that I gave you earlier, so the last, except the last one. Okay, let's come there again. What I was saying is, yeah. So is X a proper subset of Y?
Yes, sir.
Yes, sir.
Correct. It's present. Yeah. Is A a proper subset of B?
No, sir.
No.
No. Right? Because the equality should not hold. That's the only condition that should be present. That's it. So I don't think so there is any problem in this. Is it clear now?
Yes, it is.
If I have to write, so that is the natural number a proper subset of real number?
Yes.
Yes.
Yes, sir.
Correct? Is the integer proper subset of real number? Is also
Yes,
correct?
sir.
Yes.
The opposite, if is the real number proper subset of integer?
No.
No.
No,
That's not.
sir.
Yeah. So let's move to the set comprehension. It's basically the set comprehension is basically the construction. How do you construct a subset from a set? So you have been given some set. Okay, from the existing set, how do you construct a subset? This is what is generally called as a set comprehension. Okay, I'll give you some examples. There are some parts of this. Whenever you're writing in the form of mathematical form, or whenever you're writing in some set comprehension, you basically have three things that should be there in your mind. One is the generator, one is the filter, and one is the transformer. It's like that's the English term. Whenever you're writing, let's for example, you have to write the number. You have to write in the form of mathematical form, in the form of set comprehension, the square of even integer. How will you write that? You have basically three parts in that, right? So first, what are you going to do? From which number you have to take out? Like, so what are the larger subset? What are the larger set from where you have to take out the data? So that will be your basically the. So if you have to construct this set of square of even integers, okay, so you have to take out what? So what should be there in your mind is from all the integers you have to take out the even integer. Okay, so the condition that you're applying is the even thing. Okay, so square of an even integer, that's the condition that you should be applying. So the first case is from where the data are coming, so it belongs to the integer, so z. Okay, from here, so this is basically from where the numbers are taken. Okay, and then you have a filter, so you have to do the filtering. So x mod 2 equals to 0, that means whenever the number is getting divisible by 2, you have the remainder as 0. So that's the filter that you are applying, and then you are generating the data, right? So x square, the condition that you are generating. Okay, so how will you write it? Can somebody tell me how will you write this?
Curly brace x square pipe.
Yeah, x square such that x belongs to
z.
My doubt is from
comma,
intersection. It is
comma, x mod 2 equals to 0.
and then it's x mod 2 equals to 0, right? 1 second, I'll just back to you. But the first thing is what? Is the transformer, right? This is the transformation that you are making, and the database that is getting generated is from here. This is the generator, and this is the filter that you are applying, correct? So the first is from where you are taking out the data set from all the integers now, right? And then you are applying some filters, and then you are transforming those, correct? This is what you basically do in this computer. It's like pretty simple, but yeah. So somewhere if you have been given, you can just write it out. I guess not the problem for anyone. Yeah. So somebody was asking something here.
Here this filter, right? Suppose if you are saying that some number, natural number less than or equal to 20 or 30, just if they are giving number means we need to filter until that 20 target number, right?
Correct.
Okay, less than equal to means until the last number we have to take it, right? Okay.
Let's for example, yeah. So you told, let's for example, is like a square of first 5 natural numbers. Okay. So what is the generator here? So how will you write this?
Okay, 5 natural number. Then
So first you are taking out the data set from where?
natural number n, right? N 1 to 5.
Yeah, so you can directly write it like this also: 0, 1, 2, 3, 4. Correct?
Yeah.
You can write it like this, right? And then the transformation that you are making is basically square, right? X square. This way also you can write it. Or if you have to write more condition has been applied, like the square of even number that I told you, you can just apply x square. But here, if you have been given, it's like coming from the even integer, you can write it in that form also. X belongs to some integer. So integer, you write it in the form of z. And then you can apply x mod 2 equals to 0. Because basically the remainder should be 0. That generally implies that remainder is 0. Okay. So this is basically the generator that you call, sorry, the transformer. Basically the filter.
Suppose in the case here, x is inside the bracket means will it be different meaning? The generator, right? X is inside the bracket, double bracket, close bracket.
Yeah.
No, this, okay. No, the only x I'm talking about.
This one?
X include, yeah, is that right? X, if it is under, generally we are saying that they're telling that x comma y, right? Bracket in the bracket. So will it be closed? That means the last item will be excluded, the last digit.
I didn't get you. Like you're asking about this one?
No, x.
Instead of x square, he's talking about pairs there, x comma y.
Okay, if you're writing in the form of x comma y, this is what you said?
Yes, correct.
Then you can write it in this form also. Like whatever the like xy belongs to some, wherever the set it is coming from. Maybe xy are the combination of some integers only, and then you're applying some condition x equals to some y plus 2 or something. So
Right,
like
but in this case, these are not open brackets to exclude x and y. It is showing it's a pair, right?
Here it is showing it's a pair. Yeah, it's not
So when there are more than one filter, does the order matter? I had this issue with the activity question 1.6, where they asked me that the root of n should be a natural number and the n should be less than 100. I have been banging my head around that question because
Yes, I also have doubt in the same question.
Because I cannot figure out, do I need to filter the natural number first and then find the root of them, or do I do the root first and then find which of them are less than 100?
Where is that question? Can you tell me out?
Activity question 1.6, question number 3.
Okay, 1.6, question number 3. Okay, so basically that question, okay. Can you read out the question once?
Yeah, sure. Which of the following set comprehension defines squares of the first 100 natural numbers?
Square of first
100 natural numbers. The first option they have given us is...
Okay, so we can, okay, I'll just write it down. A square of first natural number. So you can write it something like this, right? n belongs to, it's coming from the natural number, and then n is less than 100. So this is correct. So this is how you generally write it.
This is straightforward, but when we talk about in terms of root of n, when we
Okay,
do
so in
not
the
modify
term
it,
of,
when we do
yeah,
not
so you
modify,
can, so n belongs to uh, the natural numbers,
and the
and
root
then you
of
should,
n belongs to natural numbers,
yeah,
and
and then you should be having root of n
N
also
less
should be
than n.
belongs to the natural number, right? This root also should belongs to the natural number,
n
and
is
then, and there should be other condition that root n should be less than some square of the 100.
see, you did that intuitively, that it's that n should be less than square of 100, but it's not intuitive to me.
Why? What's the issue here?
Uh,
Because in the question it does not give the root of n is less than 100. It just gives you n is less than 100.
Yeah, because whenever you do a square
Yeah.
root, you'll have to
Yeah.
first identify what number you're going to be using in that square root. So first you'll have to filter out the number itself.
So Rajesh, you said we have to first figure out which number we put in the square root. But
Yeah.
what if I was doing it the other way? That's why I asked what is the order of the filter. So if I just filtered out the first 100 natural numbers and then found their square root, versus if I just square rooted every natural number without any limitation and then found which of them are less than 100.
No. Okay, so one thing is you are taking, so what is your, like, from where you are taking out the data sets? Your data set is what? The n is what? Natural number only, correct?
Yes.
Yeah. And that root n is also should be natural number. That means you are getting some perfect square values, like it should be having a perfect square, right?
Yep.
Yeah, just taking out all those data set where the root n is a natural number, not a rational or a irrational or anything else. Okay, you can't take root 3 here because you already told that root n should be a natural number. Is the root 3 a natural number? No, right?
Nope.
Correct. So
Yeah.
this is the condition that we've already applied. If you have applied this condition, that means you're just taking out all those data set only. Wherever you are taking the square root of those values, you are getting a natural number. Are you getting it?
But ideally speaking, doesn't really matter which one you do first, right? If you take 100 and then you
That
apply the
doesn't
other
matter.
one, it doesn't
Any
really
of the
matter.
thing, yeah, or
You get-
yeah, you can do it in either way. So there's no point of ordering here, because in either case you are taking out 9 first or the 16 first. That doesn't matter. In the set, you'll be getting the same thing, right? Square of the first natural number, first 100 natural number.
So, sir, in that case, where you have written root over n is less than 100 square, right? Can you just
Correct.
write n less than 100? Just delete that part and write n less than 100.
Yeah.
And just solve for this. Tell me what are you doing step by step, and just solve for this.
No,
So
just
here,
think through this one, right?
I
So
think
if you
it must be 100.
so it will be a square
Root
of the
n less
first
than
10
100.
numbers.
Yeah, I need it step by step. Can you or someone tell me what steps should be followed?
See, I mean, even if you look at the question, it says squares of the first 100 natural numbers, right? So 100th natural number is 99. If you square it, it will be somewhere under 10,000, right? So the n has to be somewhere there.
Step by step,
no,
please.
so just going with this example, right? Whatever is written here. If you go this way, first you take 1, right? Square root of 1 is 1, so the 1 is fine. 2 you cannot do anything because it fails the other condition, so you leave out 2. Then you take 3, then 3 fails. 4 passes, right? So this way you can go up till 100 and you would still get only those 10 numbers. You will not get anything more.
Right.
But that's not the correct option there. No? What's the problem there?
No, because my intuition said the first one. Like I was finding no difference between n square when we're modifying it with the n square and just saying that n is less than 100. versus when we are using the square root of n should be a natural number and n is less than 100. But
Because see, the question is asking define squares of first 100 natural numbers, but if we'll take the square root under 100, then it won't get all first 100 natural numbers, because to get the squares of first 100 natural numbers, we have to keep n less than 1000.
See, whatever she is saying is correct. See, you have to just take out all those numbers only wherever you are getting root n as a natural number. Okay, and if you're taking a root n as a natural number, so you have to go till 100 ka square. You can't go till 100 only, because if you're going till 100, you'll just get some 10 values, correct? Like 1 ka square you'll be getting maybe 0, and then you will be getting 2 ka square till 100 10 ka square, even though 10 ka square is not included here.
yes,
Correct? So you're just getting 10 numbers here. If you just see n is such that n belongs to natural number, that is fine. And then you have two conditions, that root n should also be a natural number. And then you'll be taking all those n wherever you're getting the root n as a natural number. Correct? Till what value should be going? If you are checking out all those values, let's for example this sum set from 0 to 100 ka square. Okay. Let's for example you just took it 10 ka square, 100 you took. Okay, in the starting you just took 100, then you have started scanning all those values. You have to start scanning all n or x, whatever you want to call that. You started scanning, and you have to fulfill this filter. This both the filters should be passing. Okay, so you started that doing. So you did it for first case, the second case, third case, fourth case. Okay, you did it for all the cases. Like it came here 1, so 1 will pass because root 1 is 1, so there's no problem. But if you are getting 2 here, whenever you are taking 2, so root 2 is not a natural number, so you'll not be including that value. Okay, so you should not be including. Yeah,
I got it.
So you are going till 100. You went till 100 because if you are taking 100 only, so till that time you'll just be getting values from 0 to 99. 10 values you got it, correct?
Yeah.
But you'll not be taking after 100, so you just have to take 100 values. So to get 100 values would be start increasing the values, so like the increasing the generator part from where you are getting the values, right? So you'll go till what values to get the 100, right? 99 ka square if you are getting, after that you can stop it there, right?
Yeah. So
correct. So till it can be equals to 9 and less than equals to 99 ka square, whatever the number you are getting, or less than 100 from the options, whatever. If it's written in this form, it's correct. This is what I'm trying to say.
Yeah. So we're limiting the n to 100 first, and then we're inputting those numbers in the square root condition. Got it.
Yeah. Because I thought if I'll start scanning, I'll go till 100 because I have to get 100 values. That's right. So 0 to 99 I should be getting. 99 ka square I should be getting, correct?
Yes.
Yeah, so that's why I wrote it like 100 ka square.
Yeah, I got it. Thank you.
So the x, yeah, so that is what I see. Okay. So I guess this part is clear. We'll move to the next part, and then that is the relation. Okay. So if you have any doubt till now, you can just ask me till set. If you have anything from the activity till I guess this is 1.6, if somebody has told, I guess till 1.6, if you have any doubt, you can ask me.
Question number 5.
Question number 5 of 1.6, sir.
Yeah.
Okay. You have to tell me the question because I didn't join with the laptop, so
Which of the following intervals are subset of close 2 to close 3?
Subsets of tell me the options and tell me in the open, close, everything. Otherwise, the answer will get changed. Yeah.
Open bracket.
Said I wrote the question, pasted that question in chat section.
Okay. Okay. Yeah. So which of the following interval is a subset of 2 close 3? Okay, so the first option is what? It'll start from 0 to 2.3 and then it'll go from, okay, so 2.3 is not included here, right, in the first option. So I guess the first option, the options are doubled, I guess. There is something error in this question, whatever you have sent, I guess.
Answer is showing us C and D.
Okay, I guess you can just tell me that. I guess there is some error in that. Can you tell me the options? That is, the first one was 0.23.
Open bracket, close bracket.
Open 0, 2.3, close,
Yes,
right?
sir. Yeah. Then union.
Okay.
Then open bracket,
Yeah, open bracket 2.3, right?
comma 3. Close bracket.
Close.
Then see, sir, then one more open bracket.
One more open bracket.
Means, sir, you have to these two
Okay,
subsets.
okay, got it, got it. Huh.
Then intersection, open brackets 0, 2.3.
Yeah. Okay. So this option,
This is the first option, sir.
okay, this is the first option. This is incorrect, I guess. Okay, the second option.
Open bracket.
Yeah, open bracket.
Again open bracket. Then 2, 2.5.
Correct.
Close bracket.
Union.
Union, open bracket 2.5, 4. Close bracket. Then
Here
close.
it was closed or open? 2.5. It was open, right?
What, sir?
Here it was 2.5 open.
Yeah, yeah. And 4 is closed.
Okay.
Then it's divide like symbols.
Okay, minus. Okay, okay.
0, open bracket 0, 2.3. Then open bracket.
Sir, I
So
have
copy
posted
it
the
from the
options
chat.
again.
Yeah,
You
copy
can
it from the
check the
chat.
chat once.
Okay, let's discuss this one from here itself. So which of the following are the subset of 2 that should be there in your 2, 3? Okay, let's come here. So here it is. So 0. So the first option. What is the first option? Starts with, so you have to include which are the subset of 2, 3. Okay, subset means what? It should be either equal to 2, 3 or smaller than 2, 3. It can't be any value. Those are not in the 2, 3. Close. Correct? This is what the question tells. So the first option is 0 to 2.3 close, and then it's from 2.3 to 3. So that means 0 to 3 intersection 0, so it's basically the first option is what? The first option is from 0 to 2.3, and 2.3 is included here, and then it's a union, right? So it's, if it's a union, that means 2.3 is included whenever you are writing. Excuse me. Yeah, so the first option, so it will be something from 0 to 3. Okay, 0 open, 3 close, and then you have an intersection from 0 to 2.3. So I'll write it here. Yeah, so this is the first option. Okay, so the first option is basically, if you're just seeing that 0 to 2.3, this is closed, so it's like 0 to 2.3, and this is included, this is not included, and then from 2.3 to 3, so there is something 2.3 to 3, so this is included, right? Even though it's like 2.3 is not included in the this part, there is no problem, because it's like a union. So union is basically the OR. OR means it should be present in one of the two. As 2.3 is present in already this one, so you can directly write it like 0 to 3, 0, 3, 0 open, because 0 was not present in either of the two, right? So 0 open, so it will be from 0 to 3, and then you have an intersection 0 to 2.3. Okay, and then you have an intersection 0 to 2.3, and that is closed. Okay, so what should be the value now? I told you in the starting, 0 open, close 3. So what should be the intersection of these two?
0, 2.3.
0, 2.3. Either close or open, that doesn't matter, because 0 to some values, as it's not in, because I told you the subset of 2, 3 should be which value? Whichever can be 2 to 3 close also, but should be less than or equals to 2, 3. It can't go beyond that, right? Because you just have to take out the subset of 2, 3, right? So it should be smaller than or equals to 2, 3. What did I say? The subset is what? This one, right? It can be equals to also, but it should be smaller than equals to. Okay, so here 2 from 2 to 0 to 2.3, that should not be here, because 0 to some 2, it's not present in the set itself, right? So that can't be a subset of 2, 3. So the first option is incorrect. Correct?
Yes, sir.
Let's come to the second
Sir, I
option.
don't get it. Can you explain it again?
Okay, I'll explain it again. So see, what did I say? I said, see, you have been given, the first option is 0 to 2.3, 0 to 2.3. Okay, this is open, this is close.
Yes, sir.
Correct? This is, let's for example, this is a set X. Okay, and then the other set is what? Y. Y is what? 2.3 to 3. So this is basically 2.3 to 3. And this is closed, this is open for the other Y. But if you have to take the union, I told you, right? If you are taking union, this is a pictorial form. Let's, for example, this is a Venn diagram of some set X and Y. So basically, this is also included, this is also included, this is also included. Either, so all the values are included, whichever is there in the part of X or Y. Okay, this is basically or. Okay, so from
Yes,
0
sir.
to 2.3, you already know that 2.3 is included in X. So whether it's included in Y or not, doesn't matter. The value should be X union Y will be X from, X will be from where to where? 0 to
2.3.
3, right? 3. Because from till here to here, all the values are there in X. But from here to here, all the values are there in Y. Okay, you have to take the union, right? If you have to take the union, that means in either of the two, it should be present. Okay,
So
then
the
you will take
small
it.
x is union.
What?
Small x is the union.
No, this is X union. This is union of Y.
Yes, sir.
Okay, you are saying this X is union, correct? So I'll just,
Okay,
it
sir.
will make you confused. So this is basically S. Okay,
Okay,
now
sir.
it's fine, right? S is X of union of Y. Correct? Till here it's fine.
Yes, sir.
Now the remaining part is intersection of 0, 3. So intersection is what? It should be present in both the cases, right? So
Yes,
if
sir.
you have something like S1, this one, and S2 is 0 to 2.3, open or close, I don't know. Open. So it should be present in both the cases. Okay, so if it's like S1 intersection of S2, what are the values that are present in both the cases? From 0 to 2.3. Correct?
Yes, sir.
Correct? Okay. So I did, what did I in the starting, it was, is this a subset? Is this a subset of this one? A bigger S, that is 2, 3.
No, 0, 1 is not.
That's why the first option is incorrect.
Okay, sir, I got it.
Similarly, you can go for the second option also, and similarly you can check for the other options also, I guess. Right? Or should I do for the other options also?
No, sir. It's understood now.
Okay. Yeah. Anything else you have till now?
Sir, if we say set A is equals to set B, wouldn't that also imply that A is a subset of B and B is a subset of A?
Correct. That is correct. If A is equals to B, that means A is a subset of B and B is also a subset of A.
Yeah, but then practice assignment week 1, when I selected that option, it says the answer is wrong.
What? Practice assignment?
Week 1.
Yes, sir, this is my doubt also. It is saying that this is wrong. If two sets are equal, then they are equally subset also, na?
Actually, there are multiple questions in that particular assignment that I'm not able to understand, because, I mean, from my understanding, the answer should be right, but it's coming out that the answers are wrong.
Okay. Can you tell me the question number?
Practice assignment week 1, question number 2. Can I share my screen?
You can't, I guess, because you're not the co-host. Okay, I'll just open that file. But it's like something for me. It's like something else. The question I can't see the same question. Whatever you're saying. But I don't think so. This is how we generally write it. I don't know which question. Like,
So this is the question. I have
Yeah.
shared the screen.
And A is equals to B is the right answer, but it says the third option is not correct.
Yes, sir. Sir, if we click on this, this is saying that this answer is wrong.
okay.
So in the same assignment, if you look at the first question, the second option should be right there.
Okay, so it's like saying if A and B are two sets and U is a universal set and phi is the empty element, and this is in which of the following set? Okay, how are you coming to the conclusion that A is equals to B? Please let me know.
Sir, this
How are
is
you
what
coming?
I'm asking now. Can you tell the formula of A intersection union is what? What is
So
the value of
A
A intersection
intersection
union?
union should be A,
Yeah, it is A.
and B
B
intersection
union
null set would be B.
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 So
Correct.
A
So A
union B.
union B.
So the left hand side is A union B.
Correct.
The right hand side A intersection
Intersection
null
phi.
set should be A.
Null
A.
set. Null set.
Null set.
Yeah, null set, right. And null set union A is again A.
Correct.
B intersection B here is B,
B intersection B is B.
and
Yeah.
A
A intersection
intersection
B
B.
is equals to A union B, which means A is equals to B.
One second.
Yeah.
So even if the second option is correct, A is equals to B, then third option should also be correct in that sense.
Right,
No?
right.
One second.
And sir, fourth option should be correct. Now B is
When
proper
did I
subset
say
of
that I said if A is equals to B, that means A is a subset of B and B is a subset of A. Okay.
That's right.
But the option from the whatever has been given here, what did you came to the conclusion? A. What was that? A
A
union B
union
equals
B
to.
is equals to A intersection B.
This is what we came to the conclusion, right? Or something else?
Yeah.
Yes, sir. This was the only conclusion. Union
So
B
the
A union
answer is
B.
second option. So even if we don't see anything, and even if the second option is correct, then third option should also be correct.
Okay. So let me write it down. Can you repeat it? What was there? I can't see that. One second. Okay. So it was given A. So whatever you have said, the two-sided universe is a set, empty set. Okay, that is fine. And then you have A intersection universal set, and then A intersection universal is
What
always
is the value of A intersection 5?
A intersection phi is phi, and then you have phi's
Then
unit.
how is it? 5 is the element of every set.
Phi doesn't have anything. Okay,
It
so
should
if you have a set that doesn't have anything, and you are taking the intersection, that means intersection is basically the elements those are present in both the cases. Okay, if you have a is a set which have a values, let's for example 1 2 3 4 5, and then you have nothing in the other set, and if you are taking the intersection, that means the intersection should be nothing, because what is present in both the cases, there is nothing that is present in both the cases, right?
Okay, sir, I got it.
You got it right. Okay, one more thing, if you have a or b as an empty set, then also it will hold, correct?
No,
Correct
sir.
or
How?
not?
No, sir.
Why?
A
Yeah,
intersection 5
if
will be
both
5.
are empty sets, then I think it will hold.
Yeah, that will
Yes.
hold, right?
Both will empty, then it hold.
But sir, this option is also wrong.
And then you have first case a intersection. Go down. Where is the question?
Yes, sir, this is the only answer.
Okay, so yeah, so but here it is written either a and or b is an empty set. Okay, so both can be empty and then can hold. So the second option, a equals to b, if you have been given, you came to the conclusion something like a union b was equals to a intersection b. This is what we came to the conclusion, right?
Right.
Yeah. So you reached it. So then if you have anything that is a intersection b is equals to a union b, that means for sure a or b is like same.
How,
Correct?
sir? Can you explain, sir?
A union b. See, if I am writing something, if let's for example this is a and A union B, if you have something, it should be, if you have, like I'm writing B also almost same. So here you can see that A union B, A intersection B are same,
Your
right?
screen is not being shared.
Okay, you can just unshare your screen, whoever was sharing the screen.
Yes, sir.
Is it visible now?
Not
sir.
Yes, sir, you have to share screen.
It's visible, right?
Yes.
So what I was
Yes.
saying is, you have A union B equals to A intersection B. So where is that possible? If you have a data set, all the data set are almost same, like almost not all the data set are same, then only you can say that A intersection B is equals to A union B, right?
Yes, sir.
Correct?
Yes, sir.
Yeah. So this holds, like if you have been given this condition, that means there is only one condition, that A should be equals to B, right? So A is equals to B, then only it will be same.
Yes, so that's understood. But in that case, third option should also be correct. If A is equals to B, then A can be the subset of B, and B can also be a subset of A.
Yeah, I guess this is correct. If A is equals to B, okay, I'll check it. But from my point of view, it should be correct. But I'll let you know in the next session also. I'll check that. Okay.
So even in the case both the sets are null sets, even in that case, A should be the subset of B and B should be the subset of A, right?
Because in the null set you don't have anything. Yeah. So I think so. It should be correct, but I need to check it again. Okay.
Okay.
Yeah.
So if you, I mean, there are more questions in the same practice assignment. If you check the first question.
Yeah. So okay. Can we go through the concepts and then
Yeah, sure.
we'll meet? Yeah, again we have a session. So I was okay. Let's discuss first the concepts and then in the end we'll go through that. So we have completed, I guess, sets. Okay, so we have finished the set and then we came to the relations. Okay, so relation is basically, and this is one of the portion that
Sir,
you
please
can't
discuss
ignore.
about Venn diagram, no?
What
Venn diagram related questions.
Yeah, so when we'll solve some questions also. First we'll go through the all the concepts of the week one, okay, and then we'll solve these questions from the Venn diagram also. Venn diagrams like not that difficult. You should be knowing what is that union and intersection, and then the difference basically that is not used, but union and intersection, if you are aware of that, you'll be able to solve the questions. Yeah, but there are sessions where you'll be solving the questions also, okay, but today it was just for the summary, okay, for the we'll go through the questions also. We will be, again, you have a session today also in the night, so there I'll tell them to discuss the questions itself. They'll be just discussing. So if you have a doubt in the practice, so today in the night they'll be discussing, I guess it's from 8 to 10 or 6:30 to 8:30. You have to check it, okay.
8 to 10, sir.
Okay,
But
sir.
that's overlapping, sir, again.
Yeah, so that will be rescheduled, I guess, to see 6:30 to 8:30.
That would be fine.
Okay, so that will be rescheduled. Don't worry about that. So it will be done today. Yeah. So now we come to the relation part. So basically, if you have if you have A comma B and both the sets A and B are some sets that are having, it's basically a non-empty set that generally consists of some elements. And then if you are doing a Cartesian product, okay, Cartesian product, basically you are taking out one data set from each of the two sets, okay. You have been written, it's like A cross B, and basically it's like A and B, and A is coming from some set A and B is coming from the set B. So small a and small b. And then if you are doing the Cartesian product of some two sets, let's for example, if you have a set S that has some 4 values and set 2 that has some 5 values, so the Cartesian if you are doing the Cartesian product, if you are taking out one data point from each of the values, if you have
Yes,
some S1 that has some A, B, C, and D, and you have S2 that is basically 1, 2, 3. And if you are just taking out the Cartesian product, that means S1 cross S2, that means you are taking out one value from the S1 and the other from the S2, and then you are writing in the form of paired form, okay. So basically something like 1 cross A1, A1, A2, A3. So it's like all the relation that can exist between S1 and S2, that has been written here in the form of Cartesian product, okay. So all the relation that can exist between S1 and S2, so it's like a combination of all the pair that you can take out from S1 and S2, okay. This is the Cartesian product for you. So
okay.
if you are writing the Cartesian product, that means you are taking out one data set from the one set, the one element from the set, the one set, and the other element from the other set, okay. And if you're writing all the combination that can occur, or all the relation that can occur, that is basically the Cartesian product for you, okay. It's like basically, and if you're writing from, so out of this Cartesian product only, you'll be taking out some of the relations, okay, some of the data. If you're taking out some of the subset of those
So
Cartesian
can
product,
we
that
say
is
here that Cartesian product is equal to the number of subsets possible of a set?
number of that you can't say, right? See, if you have S1 and S2, you have, what is the cardinality of S1?
4.
Cardinality of S1 is 4.
And this is 3, right? What should be
Yes, sir.
the cardinality of the Cartesian, the set that you are making A cross B?
12.
So A cross B is also a set only. That is basically the Cartesian product, or basically you are taking out one of the data points from each of the sets, and then if you are making A cross B for this S1 cross S2, what should be the cardinality of S1 cross S2, like the Cartesian product of S1 and S2? What
12.
should be the cardinality
12.
of that set? It should
12.
be 12. So 12 is the maximum number that you can establish, the relation that you can establish between S1 and S2, correct?
Yes, sir. Okay, so my bad. I was thinking about the equal set. I mean, the relation on which we perform relation.
Okay, okay. Okay, so yeah. So there are some properties of a relation. Basically, we try to make like some part of a or types of a relation. Basically, we discuss three, but there are others also, but that you don't have to go through. You just have to go through this three, whatever has been discussed here: reflexive, transitive, and symmetric. Okay, that you should be knowing. And on the basis of this three, if you are aware of this three, you'll be able to solve at least one or two questions in the final exam also. It's like the one of the topic that every year you should be having some question. You can just go through the previous term papers also, previous term qualifier paper, or the term paper, whatever you want to go to see that. So every term you'll be having some one or two questions. So this topic itself is like having a good weightage, like some 10% you should be getting from this topic itself. Okay. So the first important property, or you can type of relation, is the reflexive relation. So everything, whatever we are making, that is all on the Cartesian product. Okay, so whatever the Cartesian product that we have made, that's the maximum relation that can occur between two set S1 and S2. I took the example as S1 and S2, but having S1 was having a cardinality of 4 and S2 was having the cardinality of 3, and then we took the Cartesian product. We were having a set. We got a set S1 cross S2 that have a cardinality 12. Okay, so it's like a 12 element in S1 cross S2. Okay, and S1 and S2 basically is the combination of all those values. So you are just taking out one values from the one set and the other value from the other set. Okay, and then if you are establishing some relation, so you are just taking out the subset of that S1 cross S2. That can be one of the relations. Okay, that can be a reflexive, can be symmetric, can be a transitive. Okay, we'll see that which of the relation that you are taking out are reflexive. Let's, for example, you are just building a relation R on a set S. S is basically some Cartesian product of some two sets S1 and S2, A, B, whatever you want to call that. And then R is a reflection. The word that has been underlined here is the most important word that should be taken care of. So basically, R is a reflexive if and only if for all X that belongs to S, XX should be present in R. So if, let's, for example, you have to tell that whether R is a reflexive or not on some set S. So what should the condition? The most important condition is that you can say that R is a reflexive if and only if for all X. It's not for some of the cases. It's for all X. Let's, for example, if you have a set R as 1, 1, 2, 2, and 1, 3. Okay. I'm just writing. Okay. It's been written here. What did I say? For R to be a reflexive, there's only one condition. If and only if for all X belongs to S, X should be present in R. Okay. So let's, for example, our S was this ABCD. Okay. If I have a ABCD, that means if I'm started scanning R, so I got a R something like this. Yeah, if I just got R1, is R1 a reflexive relation?
Yes, sir.
How is that? What did I say? R is a reflexive if and only if for all X
No, sir.
belongs to S.
Not
So if you are
really.
just taking out how many X are there, how many, like 1, 2, 3, 4 elements are there in S, this is the S set, the bigger set. Okay, right? Okay. And then if you are taking out X from here, the first case, let's, for example, X1, A. So A is present. That is fine. What did I say? For all X belongs to S, XX should be present. This is for all, not for two cases only. As you were having A, B, C, D, so all the values should be present. For A, AA is present. That is fine. For B, BB is present. That is fine. For C, where is the CC? What did I say? For all the X belongs to S, XX should be present. Correct? So for A is present, for B is present, but C is not present, right? And for D also DD is not present. So how can you say that it's a reflexive? You can't say that. Did you understand this, or should I repeat it?
Yes, I understand.
You got it right?
Yes.
Sir, then what's the difference between the identity and reflexive relation, sir?
Okay, I'll tell you. So identity basically will be having only 4, but reflexive can have more than that also. Yeah, so this was the first case, R1, R2, R3. Can you tell me R1 is a reflexive or not?
No. No, sir.
No.
No, sir.
No, sir.
Is R2 a reflexive?
Yes.
Yes,
Yes.
sir.
Yes, sir.
And the R3?
Yes.
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 Is R3 a identity matrix?
No.
No.
Okay, so is the doubt clear?
Yes,
The
sir. Now
difference-
it's clear. Now it's clear.
Okay. So the reflexive is fine for everyone. Is this clear to everyone? Can you move to the symmetric relation?
Yes, sir.
Yes.
Yes.
Yeah. With a reflexive and identity, there is no problem. Like every element is related to itself, or in the identity, it should be only every element in the every element is related to itself only. So it's like all those conditions should be only fulfilled in the identity. But in the reflexive, you can have those part from some other part also. So there is no problem in that. Okay. Now come to the relation.
Sir,
symmetric.
one more,
Yeah.
sir. Let's say R2 is, then we can say it as identity as well.
R2 you can say.
Yeah, right, sir.
Let's come to the symmetric relation. Yeah, so the same thing, you have been given some bigger set S, and then you have to find R is a symmetric relation on S or not. Then the condition is R is symmetric. You can say R is a symmetric if and only if for every xy that belongs to relation R, yx should be present. What did I say? You don't have to check anything on S here. You just have to check you have to check on R. So the relation that you have to tell whether that relation itself is a symmetric or not, you have to just check that relation R itself, that for every element xy, yx should be present. So you don't have to worry about the S part. Like in the earlier case, we were worrying about the S part also, like how many elements are there. Like for all the elements, x's should be present. If there are 1,000 elements, right? So all those 1,000, like the identity of that, okay, or the reflection of that should be present along with some other values also. There is no problem in that, but all those cases should be present. If I am having 1,000 elements, those 1,000 should be present, and then apart from that 1,000 there can be other relation also, but that 1,000 should be present where x should be present, correct? But here in the symmetric relation, you don't have to worry about that. You have to just worry about in the R relation where you have to tell whether the relation is symmetric or not. You just have to see whether whatever has been given in the relation R, that for all the cases xy, yx should be present. Okay, so there is no condition from the S, there is only condition on the R. Is it clear? So whatever I said.
Yes.
Everyone, is it clear for the symmetric relation?
Yes, sir.
Yes, sir.
Sir,
Yeah.
so it says for every xy, there should be a yx. So my question is, can the x and the y be same? I mean, can the x and the y be 2 and 2?
Can you repeat that? I didn't get that.
So the question is whether identity elements, right, like 1, 1, 2, 2, 3, 3, 4, 4, would they count in this?
Okay, I'll give you one example. I told, so I guess you didn't understand. I just told that if you have a set R and you have been written 1, 1, 2, 2 only, is this a symmetric relation?
Yes, it is.
Yes, sir. It is.
How did you came to the conclusion?
Because for every 1 1 there is another 1 1, the same thing, the same.
Correct. Correct.
No,
You just have to take care of R only. So for every xy, here x is y, x and y. For this case, xy is yx present. For 1 1, 1 1 is present. For 2 2, 2 2 is present, right? So if this is holding, that you can say that it's a symmetry. Correct?
Yeah. So I think I got my answer. So it can be same, and I should be checking for the couples where x and y are the same. So if there is 1 1, I should not be just ignoring that. I should also be checking it for that. Even if even if the 1 1 itself is the symmetry.
Let's for example, here it has been given 2 3. Now is it a symmetric?
No, because 3 2 is missing.
3 2 is missing. Correct. Yeah.
So
yeah. So there can be a relation 1 2. Then you have 2 1. Then you have 3 4. Then you have 4 3. Then you have 1 1. Then you have 2 2. You have yeah. This is a symmetric relation.
Yes.
Yeah, it's a symmetric, correct? I'm talking about this.
But
Yes.
why should we check for 1 1? Because if 1 1 is there, we can just ignore it from symmetric relation, right? Because
yeah,
it's obviously there. That's it. There's
it's
only
obviously there. No, just for the sake of saying, I just said that if this is x and y, you just yx is present already, so you don't have to worry about these cases where the reflective part is present already. You don't have to worry about these cases because it's already passing the cases, like the condition that you have fixed for the symmetric. You just fix the condition. You have fixed that condition that for every xy present in the R, there should be yx. For these cases, you don't have to check also. You just have to check for those cases where those are not in the form of symmetric. Reflexive. Okay. Got it?
Okay, so I have a small doubt here. For example, if we have a set that is a is equals to 1 to 1 to 10, okay, in curly bracket, then for symmetric relation, we have been given a relation that is 1 1 1 1 2
What
1.
can you say again? What is the set?
For
Your
example,
set.
yes, we have a set from 1 to 10, okay,
Okay.
and then we have given a symmetric relation that is 1 1
Okay. 1 1
2 3
2 3
3 2.
3 2.
That's it, that's enough. So we can consider this symmetric relation even if it did not cover all the elements of A.
What did I say here? See,
yeah,
what did I say here? I said that's why I was continuously saying this word. So you don't have to bother about S here. So here you don't have to bother about A. You have to just bother about RS. Okay. So for all the XY present in RS, YX should be present.
Okay,
should
sir.
be present.
Okay, sir.
If it's not occurring for one case also, you can say that directly it's not a symmetric. But that is not the case of the reflexive, right? For the reflexive set, there was a condition on A also. The condition A was what? For all the values of X, XX should be present in RS.
Yes, sir. Okay.
Did you get the point? Yeah.
Yes,
So
sir.
for the symmetric, there is no condition on A. From where the Cartesian, from where the relation, this relation is coming, there is no condition on that, right? But there was a condition on in the reflexive that from wherever this Cartesian, or if you are having RS, you are making RS as a relation on A. So you should be worrying about A also in the reflection, the reflexive. So all the element in the form of XX. If you are taking out X, let's for example X1, so X1 should be present, and that should be for all the cases, not for only one or some cases, right?
Yes, sir. Okay, got it, sir. Thank you.
So here we said that for every XY pair, right? So when I look at 1 comma 1, is that in a format of an X comma Y?
See, for 1 comma 1,
because it looks to me it's in a format of X comma X or a Y comma Y.
Okay, see, this is 1 comma 1. Let's say x equals to y, x equals to 1 and y equals to 1. Okay, x is equals to 1, that's fine for this case, but x can be 1 and y can also be 1, right? And for this case, right, okay, so the y should be 1 and x is 1. So is that present? Yes. So you can say that, okay, this is a symmetry.
Okay, got it. Thank you.
Yeah. So now let's come to the transitive part. So the transitive part is also been given. So so for the first case, okay. So on the S relation, is R1 a symmetric relation?
Yes.
sir. Yes, sir.
Is R2 a relation, symmetric relation?
Yes, sir.
Okay. Is R2 a reflexive relation on S?
No, sir. No, sir.
No.
Why?
Because 4
Because
4 is
4 is
not. Because it does not contain 4,4.
Correct. Is R3 a symmetric? So tell me, R3 is a symmetric and transitive. Which of the two? Like, can be both also, but which of the two is correct? Is R2 a reflexive or a symmetric?
Only symmetric.
symmetric.
So symmetric.
Symmetric.
It's a symmetric, right?
Symmetric.
Now?
It's not symmetric.
Not symmetric, correct. Is it clear? Now both the cases are clear, right? For everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
I have a doubt in the notion of symmetric. There is a question.
What? Can you repeat that?
I am telling my question, just wait.
I'm the only person who is not able to hear, or the voice itself is very low.
Yes, sir. It is very low.
Okay. So I guess you have to reconnect, or maybe say a bit louder, or maybe you can post it on the chat box itself. I'll take care of that. Okay, let's come to the transitive part, and this is the relation that is the final one out of the three. The transitive is the final one. Okay, so the transitive relation is, again, you have a Cartesian product S, and you're just taking care of like whether the given relation R is a transitive relation on S or not. So the same thing for whatever we have been doing for the symmetric and the reflexive. Again, you have to check whether R is a transitive relation or not. So R is said to be a transitive relation if and only if for every pair of element xy, yz that belongs to R, xz should be present. So one more condition here, like one important things to understand here is, for the transitive, what did I say? If and only if for every pair of element xy, yz, if, let's for example, if you have a relation xy, okay, and for that case, if you are not able to find yz, then you don't have to check for xz. See, understand this point.
Yes,
if
sir.
you have a relation R, and if for that case, so the basic thing in transitive is, if xy and yz is present, okay, then only you have to take care of xz, and if that xz is not present, you can directly say that is not transitive. But if for any data set xy, if yz itself is not present, then you don't have to check for xz. So there is two things. I'll repeat it again. If for the transitive, for a relation to be a transitive, you have to just check for all the cases. If xy and yz is present, then you have to search for xz, and if xz is not present, you can directly say that it's not transitive. But if you are going and scanning, if for xy, if you're not able to find yz, then you can skip that. Okay, you don't have to take care of xz at that point of time, because yz is not present itself. Is it clear to everyone?
Okay, so you mean if
Yes, sir.
we have xy and we don't have yz, then we should not care about xz, and that
Yeah, you should
relation
not
is
be caring.
already transitive.
Yeah, correct. No, and yeah, that is fine. But for that particular element,
Yes,
for
yes, for
elements,
that
for
particular
example, 1, 2, if any element that's not starting with 2, you don't have to take care of anything else. From 1, 2 point of view, this relation is transitive. But
transitive.
again, you have to check for each and every element. This is what you have to
Yes,
take care. Okay.
yes, yes.
So I'll just give you some example for the transitive case. Is this clear to everyone?
Yes, sir.
Yes, sir.
Not yet, but I think with some examples it will become clear.
Okay. Yeah. So let's, for example, this is the S bigger set. That is 1, 2, 3, 4, 5, 6. Okay. And then this is a reflexive. Reflexive. The transitive. Let's put. You have to tell me whether it's a transitive or not. I just have 1, 2. Is it a transitive?
Excuse me, sir, I have sent my
Yes.
question.
Yes, sir. Yes, sir, it is transitive.
It's a transitive
Yes,
relation.
sir.
Yes, sir. It
2,
should be
1.
transitive.
No,
It's
it
a
is not.
transitive.
But isn't this supposed to be on pairs?
Then there
Okay.
should be ordered pair.
What are the conditions that I told? Just read it again.
For every
R is
pair
said to
of
be a transitive if and only if for every pair of element x, y, and y, z that belonging to R. So for this case, if I am writing this as x, y, is there any y, z?
No.
Is there any other element
No,
that
sir.
starts with 1, 2?
No, but my question is, this is not even a pair, right? Okay, now it's pair. Okay.
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 Now
Sorry. Yeah, that was my bad. Okay. Is it fine now? Okay.
Yeah. Okay.
For
Yes,
x,
sir,
y
it is.
now, where x equals to 1 and y equals to 2, are you able to find any yz pair where
No. So this is not
No, sir.
transitive.
This is transitive.
Okay, so you are not able to find, right? If you are not able to find, what did I say? If you are not able to find
This is
any element that
transitive.
starts with yz, you don't have to worry about xz. It's already a transitive from this 1, 2 point of view. Are you getting my point?
Yes, sir.
Correct? But let's, for example, if I'm just writing it here, 2, 3. Now tell me, is this a transitive?
No.
No, sir, it is not.
Correct, because for xy, for 1, 2, am I able to find any element that starts with 2? Yes, right? 2, 3.
Yeah.
If I'm able to find that, then 1, 3 is compulsory should be there. It should be there in this relation. If it's not there, then it's not a transitive.
Yes, sir.
Is it clear? So whatever I
in
gave 2 examples. The first example was R1 was 1, 2. This was transitive. R2 1, 2 and 2, 3. This is not transitive. Why? Because for the first case, for xy, we were not able to find yz itself. If I'm not able to find yz, then you can directly say that this is transitive. Okay. But for this case, where I'm able to find for 1, 2, I'm there, like I'm here, I'm able to find a pair where it starts with 2. Then for 2, 3, it should be xz should be present, where x is equals to 1 and y z is equals to 3. Is 1, 3 present? No. Then you can directly say that it's not a transitive. Is it clear to everyone now, the transitive relation?
Yes, sir. So
Yes,
there is
sir.
a doubt in
Yes.
comment section.
Okay, I'll take that in the end after finishing the
So I have
conceptual part. Yeah.
Can you scroll up a bit so that I can see the main set? The S, yeah. So if I told you R3 is equal to
R3
is equal to a pair of 1, 2
Hmm.
and a pair of 2, 1. That's it. So again, I look at it as a pair of x, y and a y, x instead of an x, z.
Oh, okay. One second. What did I say in the starting? If you are taking,
so I guess the same rules apply. So there is
same
nothing,
rule applies here.
So there is nothing stopping an x and a y and a z to have a same value, I guess.
Correct.
Yeah.
There's no, yeah.
Got it.
See, is it a transitive R3?
No, it is not.
No, sir.
Yeah, because for 1, 2, you have to search for all the cases where the element starts with 2. Okay, and if you are able to find, because you are able to find it here. So for this case, 1, 1 should be present. 1, 1 is not present, so it's not a transitive. Got it?
So and if I see a 1, 1 in the wild, am I supposed to consider that as an XY as well?
See, now 1, 1 is present.
One symmetrics, right?
What?
The first one, 1, 2, 2, 1.
Acha, now tell me, is this a transitive relation?
Yeah, this is transitive.
Yes, sir, it's intransitive.
Yes.
Yes, sir, it's a transitive.
Yeah, forgetting
No,
something.
sir.
Is it a transitive?
Yes, sir, it's intransitive.
No, sir.
Yes, sir, it's transitive because 1, 2 is there, 2, 1 is there. So
For
1, 1
2,
is there.
1 and 1, 2, 2, 2 is not present.
Correct. What did I say? I told you have to check for if only for every pair of element x, y, y, z belongs to R, x, z should be present. What did I say? For each and every pair. Then you don't have to just check for only one case or two cases. You have to take care of all the cases. You don't see for 1, 2, 2, 1 is present. 1, 2, 2, 1 is present. So 1, 1 is present. That is fine. But for 1, 2, you have seen. What about 2, 1? You have to take care of 2, 1 also, right?
Yes, sir.
Okay. So for
And
2,
it is
1,
not transitive.
2, 1, what are the elements that starts with 1?
1, 2.
1, 2, and 1, 1.
Correct. So for 2, 1, for this xy, what are the value that starts with 5? It's like 1, 1, and the other is 1, 2.
1, 2.
Correct?
Yes.
Okay. So this is yz, and this is y1, z1, and this is y1, z2. Correct? So for this case, for 2, 1, 1, 2, 2, 1 is present. That is fine. But for 2, 1, 1, 2, is 2, 2 present?
No, sir.
So that's why it's not that.
Yeah. So I guess this is clear now. I'll just
Can
have
you
one.
repeat it,
Sir,
What?
Can you repeat it again? Because sir, 1, 2, sir, is present in the set, sir.
So
But
1,
2,
2 is
2 is
present.
not
2, 2 is not present, right?
So for 1, 2, there is 2, 1, and for 2, 1, there is another element 1, 1. Sir, it's a transitive.
See, I have a relation R.
You have to check for every pair.
If I have checked for 1, 2, for 1, 2, 2, 3, and then you have 2, 4. So if I am getting 1, 2.
Sorry for the interruption, sir. Sir, your screen, sir, it's too much bigger and.
But you're not able to see my screen or what?
Yes,
No,
sir.
it's visible.
It's not clearly visible or what?
It's okay.
No, sir, it's visible.
It's visible to me, sir.
Okay. So what did I was saying that you have to take care of each and every element. For 1, 2, let's for example, this is x and this is y. For 1, 2, what are the other element that starts with 2?
2, 3.
2, 3 and 2, 4.
And 2, 4. So for this case, what should be present to make it a transitive?
3, 1.
1,
1, 3.
Correct? And for this
And
case,
1,
1, 2, 2, 4, 1, 4 should be present. Just for this element, just for this first element. Correct? I'm not talking about anything else, right? So this just for the first element. Now, if we have checked for 1, 2, okay, and if you are not able to find, even though if you are not able to find for one case, you can directly say that this is not transitive. But if 1, 3 was present and 1, 4 was also present, then you would have checked for 2, 3. So you would have went to 2, 3 now. And now for you, 2, 3, you have to scan all the values where it starts with 3. If you are able to find any value that starts with 3, then you have to take care of exit. Like you have to, at that time, you have to pair it out. If you are able to, if there is no value that starts with 3, then from 2, 3, this is transitive. Now come to the 2, 4. Okay, now for 2, 4, you have to check, is there any element that starts with 4? Now you have to scan it again. And now you can see that there is no element. Now you can move to 1, 3 and then to 1, 4, right? So this is how you have to do this for the transitive. Is it clear now?
Yes, sir.
Yes, sir. It
Yes.
means if any pair is a transitive in a set, then we need to check for the other pair. If that pair is not transitive, then we can say the relation R is not transitive. So it is right, sir.
Correct.
Okay, sir. Thank you, sir.
Yeah.
So if
So for
1, 2, 2, 3, 1, 3, and 2, 4 are present,
okay, 1, 2.
if you scroll up, if you have everything except 1, 1, 4.
So 2, 4, 1, 3.
That's
and
it.
That's it. Tell me, is it
Then
a
for
transitive
1,
relation?
2, for 1, 2, there is
Yeah.
2, 3. So then I
Okay.
look for 3, 1, with 1, 3, which is there.
1, 3. Yeah, this is there.
Yeah. So this makes it transitive, no?
No. You have to take care of
No.
all those values that starts with 2. So is there anything else that starts with 2? See,
Which is
for
2,
this
4.
case, what did I say? For XY, you have to scan for YZ. Correct? So this is the first YZ. So this can be Y1, Z1. Again, you have to scan. So is there anything else that starts with 2? Yeah, 2, 4.
2, 4.
Correct? So you have to take care of 1, 4 also. If 1, 4 is not present, you can directly say that this relation is not transitive.
Okay. Then if 1, 4 is present, then is it transitive?
Then 1, 4, then you have to check for 2, 3. Now you have to take care of 2, 3. Now you have to start with 2, 3 again. Now you have to take, is there any element that starts with 3? No. Okay, if it doesn't, then from 2, 3 point of view, it is transitive. Now you come to 2, 4. Now 2, 4, is there any element that starts with 4 apart from, is there any element? No. So from 2, 4, this is transitive. Now you come to 1, 4. Okay, is there any element that starts with 4? No. From 1, 3, is there any element that starts with 3? No. That means a transitive relation.
Okay.
Got it?
Got it. Thank you.
Excuse me, sir. I have one doubt.
Yeah.
Can I ask, sir? As you shared, is in any set if 1, 1 is pair present, then it's in transitive. But if any set is 1, 1 and 2, 2 and 3, 3 is present, then it means is that is also a transitive.
Yeah, that is also a transitive.
It means every
See.
reflexive relation is transitive.
Okay, if I have a set A, B, C, and D, this is the, and then you are taking the Cartesian product and then getting the relation R, and that is basically AA, BB, and CC. What did I say for the transitive relation? For all XY, you have to scan for YZ, right? And if XZ is present, you can directly say that's a transitive relation. For this AA, is there any other element that starts with A?
No, sir.
No. So from
No.
AA, this is fine. Is there any element that starts with B apart from this BB? Sorry,
No.
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 For CC, no. So you can directly say it's a transitive relation.
Okay, sir. There is nothing to be need. All the elements are need to be present. If any two pairs are present, then we can say this relation is transitive.
See, I told you for the transitive relation, you don't have to worry about the set S. Like you have to worry that it can't be like, so if I'm saying that DD, so there can't be a relation EA, right? Because E itself is not present in your bigger set, right? So E can't be there, right? So let's, for example, I'm just giving you S has been given A, B, C, D. If I'm giving you a relation R1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Is there transitive?
No, sir, because 5 is not present in set A.
Correct. Because 5 itself was not present. Because whenever you are doing the Cartesian product of S cross S, you'll not get 5 cross 5, right? There's no possibility of getting a 5 5 as a pair, right? Because whenever, okay, so it's like S equals to 1 2 3 4. So there's no possibility of getting 5 5, right? So that's why it can't be, even it can't be a symmetric, can't be any relation, right? Because 5 5 itself is not present in the Cartesian product of your Cartesian product. Okay, is it clear to everyone?
Yeah, so there's a question in the chat and I would like to check.
Okay. So I guess this is till the transitive relation. So we'll take some doubts and then again for the remaining topics we'll discuss it in the next session. So I'll take your doubts now.
Sir, so from
Yeah,
functions,
this one.
we'll be learning that in the next class.
Yeah, function will learn in the next class. If you have anything, like a simple question, I'm like simple, I mean the smaller question, you can ask me.
So,
Yeah, and one more thing. So whenever you have a TA session, you can ask your anything, like ask your doubt, anything from that week. Okay, so today also you have a doubt session. So we have been in every week you'll be having some 3-4 session where you can directly ask your doubt. Like all the doubts can be resolved. Okay. Whenever you have an instructor session, so you'll be having 3 instructor that will be taken care by me, or we have a 2 other like math instructor apart from me, like she's Lavanya and then Samiksha. So next session maybe she'll be taking that. So there will be mostly will be taking care of. In the first session we'll discuss all the concepts. So today we were not able to discuss because of some of the doubts that I took. So mostly we will do a summary session, 2 hours of summary session that will discuss all the concepts. In the next session, generally we take all your doubts like the activity practice, whatever you have, and then in the end, in the Tuesday session, we'll just solve some problems, maybe 10-15 problems that we'll figure it out and then we'll solve. So those are the 3 sessions that will happen every week, like Friday, Sunday, and the Tuesday. Okay, as your deadline is Wednesday. But apart from that, you have 4 other sessions that will be taken care by the TAs. That also you can, if you are free, you can go there and you can just clear your doubt. You can just join for whatever time, half an hour or whatever the doubt you have. You can go there, you can clear your doubt and you can exit. Right? These are the sessions where we'll be all discussing the summary and then we'll be taking out like we'll just first discuss the conceptual part and then only we'll be discussing the other thing. Okay.
So are the TA sessions recorded?
Those won't be recorded, so that's why it's like a office hour. You just go there, you just solve your doubt for half an hour or whatever the time you want to go there. You can be there for full 2 hours or whatever the time it has been scheduled, but don't be recorded. Some sessions will be recorded, but that will be mostly the PYQ sessions and all those sessions, but not all the sessions. But this all session that will be taken care by us will be recording. Okay.
Okay, sir. So will today's TA session be rescheduled?
I'll reschedule it from 6:30. Everybody is saying so. I'll reschedule it from 6:30 to 8:30. Okay, so this was the first week. We were just planning it out, which timing would be the suitable and all. So after getting the review from all you, like all of you, I'll be just rescheduling all the sessions. Like today's session, yesterday also I got some review. Then I'll just reschedule it from 6:30 to 8:30. After the session will happen.
And can you make it to 6 to 8?
6 to 8 again. Okay, then I need to ask the people who will be taking the session. Okay, or okay, I'll do that from 6 to 8. There's no problem in that.
So just one more thing, I don't have access to the discourse. So I mean, in case if
Yeah, it will be there. Wait for 2-3 more days, and it will be it's like getting uploaded for each and every people. So it will take some 1-2 more days. Most of the people are not present now, so it will be done in 2-3 days for sure.
So when will we have the next class now?
I have joined the Discord. There will be a link, I think.
Yeah, so discourse, yeah, and for to directly you can send share your questions on the discourse. You can share to me also, so you can just write it out. My mail ID also, you can just share it with me also. You can just take out your mail like Vishal at the study. You can just mail it out also, or you can just tag me on the discourse also. Okay, you have whenever you have a doubt. I guess there is not much, one or two questions was there because most of the people are not there, so that's why now I guess the TAs are not present because they also didn't got the access for the maths one till now. So it will be done in 2-3 days, and after that it will be totally fine. The discourse also. So you can just tag me also, and then you have two more people. So you'll be having altogether 5 people. 3 will be your instructor, and 2 will be your TAs. Okay, for whole this 4-5 months, whatever the timing is there for the maths one. Okay, so
In
you
order
can
to
just
tag you, can we get your ID?
yeah, you can directly tag me Vishal at the so whenever you will tag me at the Vishal, you get me. My mail ID is
Discourse can
simply
be
Vishal.
joined by the students who have student ID, no?
What's that?
Only student ID persons can join this course, no?
Any student ID? What?
Only
You will
student
get
ID
access to this
students
course
can join
after.
the discourse.
Yeah, you'll get the access in 2-3 days.
Sir,
Sir,
I have the
can you check the chat?
Okay.
Sir, just one more question. Where I can view the recorded section because I haven't seen anything shared till date.
Okay, that'll there on the YouTube. You can just go to the IITMPS that YouTube channel, and then you'll be having maths one
Right, sir.
section.
Understood, sir. Latest one that I can get it. Okay, thank
Yeah,
you.
so you can get it from there.
Sir, how do we solve this?
Yeah, so there's a question from where is this? What is the minimum number of elements of the guardian? So that needs to be added to the R such that the relation becomes. So I am not aware of S and R. How can I say directly?
Can you
So
share my screen
Sir,
for
this
half an
is
hour?
question number 8 of activity 1.10.
1.10.
1.10.
1.10. Okay. See, it's like what is the minimum number of relation, number of elements of the Cartesian product S process. So what is S here? So you have to take care of that, and then only you'll be able to say what's the number of.
So it's a sub question. So there's
Yeah,
more
it's a sub
context to.
question.
Oh, got it.
So you should be knowing that S cross, like S, what is that S, and then what is the relation R, and then you have to take it out.
But
What should
sir,
be the value?
if I
Yeah.
think of it, we discussed that the original set shouldn't matter when we're discussing about symmetric. It's only important to see when we are checking for reflexive, right? So I would argue any. So let's say this was asked by me without any other context. So the correct answer should be one set, right? Because assuming the x and the y is same, and that will make it symmetric.
But here there is no context of what the relation R is, right?
So
No,
R
it's
is not, you're not known to you, right?
a sub question, sir.
Yeah, it's a sub question. You can't say directly.
Oh, okay.
Got it right?
Yes, sir. Yes. Thank you.
I have taste the R.
What? Okay.
R.
Okay. So this is your. So this is a snail and frog, and then you have bird, and then so okay, and then you have fox, frog, snail, fox. Okay. 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 Now tell me what should be the okay. What are the other element that should be adding it to make it a symmetric relation? First, tell me what is symmetric.
For every xy, there should be yx.
Correct. And you should be bothering about the R only, right? So in the snail frog, is frog snail present?
No.
No.
Correct. So for bird is present. So fine. For fox frog, is the frog
No.
fox present? No. So the second element that should be added. For the snail fox, is fox snail present?
No.
No. So the third element. So you should be adding 3 more elements to make it as a symmetric relation. Okay. Okay. Is it fine? Whoever was asking this question.
Yes, sir. Yes, sir. I didn't know it's a sub question.
Yeah. Okay. So for the transitive relation, what did I say? For the transitive, if xy and yz is present, then only should be taking care of xz. If yz itself is not present, you should not be worrying about xz. I guess Kiran, it is fine, right? Now this is clear. Okay. And then Ajay Kumar, this is a question that is fx is n plus 1 by 2. I guess this is for even 1 on 2 we'll discuss again on the Sunday. So don't worry about that 1 and on 2. We'll discuss that on the Sunday. But it's like not that difficult question. It's a simple one only. Okay.
Sir,
Yeah.
but if R is given A, B, C and R1 is given AA, then is it transitive?
It is, yes.
Yeah, it's a transitive. You just have only one term, right? A. Even though if it's only one term, then you can't directly say it's a transitive because for any one term, the other term is not present, right? See, if I'm giving you a relation R, that is 1, 2, that's it. That means what? 2, 1 is like, is there any other element that starts with 2? No. You can directly say that's a transitive. So whenever you have a relation where only one element is present, so directly you can say that's a transitive. Either it can be a symmetric or the transitive, that depends from where it is coming. Okay. But for the transitive, you can directly say that 1, 2, it's like, or 1, 1, it's directly a transitive relation, right? Because for 1, 2, there is no other element that starts with 2. Even though for 1, 1, there is 1, 1, and then you have 1, 1, and for 1, 1, 1, 1, you have already a 1. So you don't have to worry about that. Okay. Is it clear?
Yes, sir. Okay, thank you, sir.
Yeah.
Sir, I've shared a question in the chat box. Could you please check that?
Okay, you can tell me the question number. I'll just go to that.
It's actually like a it's a diagram, so you'll have to check that.
Okay. So is it a question from a graded or practice from where?
It's a practice assignment.
So practice assignment, tell me the number. I'll just go through there.
Practice assignment 1.
Okay, practice assignment 1. What is the question number?
The first question.
Sir.
Yeah.
Sir, I have doubt from function. Can I ask?
The function we'll discuss in the next session. Okay.
Okay, sir.
Okay, so basically it's a problem that Devendra has 3 sons, so Jatin, Ravi and him, and Ravi has one son named Rathi. Ravi has one son named Rathi. Okay, fine. And then Hem has 2 sons, Avi and Manish. Family tree has been given. Let us define there are 2 sons. Okay. Can you see my screen? Sorry. Now we have to tell about, so you have been given that there is a relation R, AB, and then there is a relation S, AB. A is the son of B and A are first cousin. The parents are sibling. Fine. What's the doubt here?
So I think the second option should be right.
Okay. What has been given, the answer?
It says that the second option is wrong.
All the other are correct.
I don't remember the other ones. I think I selected the second and the fourth one. I think I'm not sure. I just unticked it so that I could, share the screenshot.
Okay. S. Okay. A is the son of B. So where's this? Hey, how can B be correct? Like, if A is a son of B, then how come B is a son of A? It's not possible, right?
No, so it says, but Rabi Rati is not an element of S, which is correct.
Okay, it's asking. Okay, got it. Okay, I guess there's some error or what. Like B to for sure it's not correct. Sorry,
B should be correct, right?
B should be correct. Yeah. I guess there's some error or what. Like, see, one thing is again. I mean, wait for a minute.
Sir, D is also correct.
Yeah, D should also be correct. D is correct. Yeah, D is also correct.
1 second, I'll have to. 1 second, I'll just opening my laptop.
Can we even make a relation like that out of S? Because I don't think any pair in the S would satisfy this relation.
You were saying practice one, right?
Practice assignment week 1.
Hey, what's the answer been given to you?
So according to me, second and fourth option should be correct. If I click on,
yeah, second is correct.
Now it's saying it's correct. Earlier it was not saying it's correct.
Yeah. Okay. Okay, it's fine.
And so a cross question regarding this.
But fourth should also be correct, right?
Where is that fourth? Jatin and Devendra belongs to S. That is fine. Jatin is the son of Devendra. That is fine. But Rati, how is this possible? Rati, the grandson of Devendra, right? It's not a immediate son, right?
Yeah, so it says it's not an element of S.
It should not be.
So then this should also be the right answer, right?
This should also be a right option. According to me, this should be a right option.
Yeah, so this time it's switched.
Okay. Yeah, but it's whatever. It's like the option fourth is also correct from my point of view. So fourth is also correct. I need to, yeah. So fourth is correct. I guess there are. How can there is okay? I guess there is 4 assignment has been given to you, right? Practice assignment. Okay.
But this practice assignment is not visible to me.
It's the same problem. It is not visible to me also.
So practice assignments keeps refreshing. If you refresh it after solving all the questions, you will get a new set of questions. Some may be same, some may be different. So
yeah, and I'm facing the same problem. Like for me, week 1 and week 1.1 are the same set of questions.
Oh.
No matter
so they're like jumbled questions. So you need not to worry about the practice. Just for the practice. even though the graded also will be jumbled, but yeah, so practice we are just given a lot of questions so that you can become good in that. So I guess from whatever the question that I can see from my point of view, fourth option is correct. It should be correct.
Sir, I wanted to ask a cross question regarding this question. So here I would say the relation will have no sets, right? Like no pairs, no elements, because there can't be a first cousin who's the son of the second person.
No, R and S are two different relations.
R and S are two different.
Oh, both are relations. Oh, okay,
Yeah.
okay. Sorry. I thought R is based on S. Sorry.
Yeah. So okay. So the remaining portion we'll be discussing in the Sunday session. Okay, when I'll be coming. Okay.
Sir, there are two sessions are overlapping in the evening
I
session.
told you
8
in
to
the
10.
starting itself, so the TA session will overlap. There's no problem. So, but those are just for the doubt clearing. Okay, whenever you are getting the time, you can go there. You can ask your doubt and then skip. Like, but the sessions which will be conducted by the we'll be conducting that won't overlap. Okay, so I told you in the starting there will be a lot of TA session. So we can't. There can't there is very less chance that the TA session won't be overlapping, right? But the instructor session won't be overlapping. That we can assure you. Okay, so the 3 session that happens on Friday, Saturday, Friday, Sunday, and the Tuesday, that won't overlap with the other courses. But apart from that, the TA session may overlap. So okay, that you have to manage that. Okay, so you can take out out of 4 or 5, whatever is the TA session, you can just collect your doubt. You can go to one session and can clarify your doubt in one session, right? Is it clear?
Okay, sir.
Yeah. So you have my mail ID. You can just post it on the discourse, your doubts and all. We'll meet again on the Sunday. Okay. So I'll close this. Okay. If you have a doubt, you can just mail me or put it on the discourse so that the discourse many people can see that anybody can clarify your doubt.
So could you please leave your email address in the chat?
Yeah, I visal@study.itm.ac.in.
Sir, my maths week 2 courses are not yet released. All the other 3 have been released.
What maths?
Maths 2 week 2 courses are not released.
Maths 2?
Maths 1 week 2, sorry.
Okay, it will be released by today. Maybe most probably it's released on Friday, no? So don't worry.
The other 3 have been released.
Don't worry about it. It will be released today.
And I have only one practice assignment from the week 1, not like 4.
It's fine. It's fine. All the questions are same, only the numbers are different.
Okay.
Sir, to submit the graded assignment week 1, it's a 31 last date, right?
Correct.
But I got a mail tomorrow and they're saying it's 7th Feb. Sorry.
Then
yesterday.
it would have been extended. Yeah. So the first week or second week will get a much longer time.
But
to
there is
submit.
no change on the graded assignment
I think 7th is the deadline for week 2. Because week 2 lectures are also uploaded, right?
Yeah, so from my point of view, what I can see is this is 31st has been given for the first week, and the 7th Feb is for the next week.
Week 2 is 7th.
Yeah, week 2 is released. How can somebody saying it's not released? Already released. It's there on the portal.
I don't see for me.
Okay. So you can just refresh. I guess there.
I think you have to refresh the page, then only come back. Even I also have the same issue.
And what I'll advise you to, whenever you're solving, go through the practice the previous term papers along with each week. So, okay, you can get the papers, I guess, maybe from there are if you're not having the previous term paper, I guess there would be some of you would be for sure will be having. So you can just go through those questions also.
YouTube Google.
Do you have any dumps or something previous old one, right? Old exams, right? Do you have any share link? Share phone?
What?
No.
Like, is there any site or something from where we can download these previous question papers? Is it available somewhere?
I guess on the portal it's not uploaded yet, but okay. I'll ask the team to upload some of the papers. Okay. But mostly, I guess in the tomorrow session they'll discuss the previous term papers. The TAs will be discussing with you the questions that are there from the week. Do attend that at least. Yeah. Okay.
Sir, can I get the recorded session of this class?
This class will be there on the YouTube,
From
so do
where?
not worry about that.
On
Okay. Okay, so I'll just, if you don't have anything, I'll just close it out. We'll meet again on Sunday. Okay.
Bye. Bye, Josh.
Thank you so much.
Yeah, thanks everyone, and I guess.
Thank you, sir.